Welcome to another physics class. During our last lesson, our topic was Newton's third law of motion. And by then, we stated Newton's third law of motion as to every action that must be equal and opposite reaction. We said further that Newton's third law of motion can be also called the law of action and reaction. At the same time, we talk about the key point or the fact about Newton's third law of motion. Lastly, on that day, we talk about examples of Newton's third law of motion. Then we now promise that today we are going to continue from where we stop. Today, we want to look at effect of Newton's third law of motion on body inside elevator or lift. Effect of Newton's third law of motion on the body inside elevator or lift. The body inside elevator must comply with Newton's third law of motion. That is, there must be action and the reaction must follow. The cases will be divided into 4 parts. The first one we are going to look at is elevator stationary or at rest or moving upward or downward with constant velocity. Body inside elevator at rest or moving upward or downward with constant velocity will not gain or lose weight. Why? Because the acceleration is equal to 0 since the velocity is constant. So the first diagram will look like this. First diagram. That is when the body is inside elevator, but the elevator is at rest or moving upward or downward with constant velocity. This is X direction, while this one is Y direction. The reaction on the floor of the elevator on the body, which is R, and the weight of the body inside the elevator on the floor will be W. Since we said it is moving with constant velocity, then A will be equal to 0. And once A is equal to 0, R will be equal to W, that is, the weight of the object inside the lift, which is the action, will be equal to the reaction produced by the floor of the elevator. And once A is equal to 0, there will be no acceleration at all. So the reaction will be equal to weight of the body, which comply with the law of Newton's third law of motion. Now, as I said earlier, according to the diagram on the board, R is the reaction on the floor of the elevator on the body. We said it will be equal to W, which is the weight of the body, which is the action. And at the same time, we said A will be equal to 0. Since A is equal to 0, because it moves with constant velocity, then the resultant force acting on the body also will be 0. The resultant force acting on the body is 0 because A is equal to 0. Now, case 2, elevator moving upward with constant acceleration. Elevator moving upward with constant acceleration. When this one occurs, that is when the elevator is moving upward with constant acceleration, definitely the body inside the elevator or lift will gain weight. Why is it that we gain weight? Because the resultant, the reaction from the floor of the elevator produced on the body is greater than the weight of the object. Therefore, there will be gain in weight of the body. First diagram, like the first one we treated, is as this. First diagram. As we said, there will be gain in weight of that object. Then the reaction produced by the flow of the elevator, we say it will be greater than the weight of the object. If you look at this, our two vertical arrow, now this is the weight of the object now that will produce the action. This is the horizontal, that is the x-axis. Mind you, this one is dealing with vertical motion. So the x-axis automatically is equal to 0. So it remains the y-axis. So along this way, vertical row, that's the reaction from the floor of the elevator. And you can now see, if you measure from here to here, then it is greater than from here to here. That to show that the reaction from the floor of the elevator is greater than the weight of the body. So from there now, at the same time, the resultant upward force will follow the direction of the acceleration. The direction of the acceleration, according to this one, since it's moving upward, will be upward. So from what we have seen so far now, we can now add that the resultant force F will be equal to, since the reaction on the floor is greater than that one will be equal to R minus mg. That's the resultant force from on the body. At the same time, the accelerating force, which is the same force, will be equal to ma. That is, since the body will accelerate up. So since this one is F and this one also is F, we can now say that the resultant force F will be equal to R minus mg, which is equal to ma. Now, make this reaction as the subject of the formula. We are going to have R will be equal to ma plus mg. So from there now we are going to have R will be equal to m, since m is constant, a plus g. We said that the reaction from the floor of the elevator, which is greater than the weight of the object. Now, to comply with the Newton law of motion, this reaction is also equal to weight of the object inside the elevator. But you can see that if you look at this equation now, the reaction on the floor of object, according to this, since it is moving upward, will be greater than the weight produced by the object on the floor of the object. Now, to comply with the Newton's third law of motion, the reaction will be equal to the weight of the object, which is the action. This is number 3 case, that is elevator moving downward with constant acceleration. Elevator moving downward with constant acceleration. When this one occurs, the body inside the lift or the elevator will lose weight. Why? Because the reaction on the floor of the elevator is less than the weight of the object, or in another way, the weight of the object on the floor of the elevator is greater than the reaction on the floor of the elevator. So from there now, we can now say that unlike this one, when it is moving up, that the body gain weight. Under this one, the body will lose heat. Then the first reaction, first diagram, will look like this. This is the reaction. So in the reaction, we say it's less than the weight. So we have R, but the weight is greater than the reaction on the floor of the object, as we said, for the horizontal axis is usually 0 because we are dealing with vertical motion. So this is the weight of the object, which is the reaction. And as I said, the weight, which is the reaction produced by the body on the floor, is greater than the reaction. So you can now see the length of this from this point to this point is compared with from this point to this point, the weight is greater than the reaction. So, but the resultant force on this object, since the acceleration is moving downward now, then the resultant force on the object will also be in the direction of the acceleration, which is downward. So we are going to have it like this. Then the resultant force F will be equal to mg minus R. Mind you, it is mg minus R since the weight is greater than the reaction. But unlike this place now, R minus mg, since the reaction on the floor is greater than the weight of the object. So from there now, the accelerating force that will act downward be equal to ma. Now, since if you look at these two equations, this one is force, this one is force, then we can now say that F, that is the resultant force on the object, which is acting in the direction of the acceleration, be equal to mg minus R, which is equal to ma. So compare the two now. Mg minus R is equal to ma. Now, making R, which is the reaction, as the subject, then R will be equal to, that will be mg minus ma. So from there now we are going to have R will be equal to m is the same, so the mass of the body inside the leaf is the same, and that's g minus a. And since to comply with the Newton's third law of motion, so this one is the reaction, then it will be equal to weight of the object, which is the action. Case number 4, elevator falls freely under gravity. Elevator falls freely under gravity. When this one occurs, the body inside the elevator become weightless. That is, under this one, our A, that is the acceleration, will be equal to acceleration due to gravity. So when this one occurs, the body inside the leaf become weightless. So it become weightless. Since A is equal to G, so it has no weight at all. And when the body is weightless, then it now float about inside the leaf. It will be floating about inside the leaf because it has no weight. Now, from what we have seen, under the effect of elevator, the effect of Newton's third law of motion on the body inside the elevator, on the case number 1, we said when the elevator is moving with constant velocity, definitely the acceleration will be equal to 0. Then we said the resultant force on the object will be equal to 0. Therefore, the reaction on the floor of the weight on the floor of the elevator will be equal to the weight of the object, which is the action. Then point number 2, we said when the elevator is moving upward with constant acceleration, when it's moving upward, we said the body inside the leaf will gain weight, and the resultant force on it will move in the direction of the acceleration, which is upward. Therefore, we now say the reaction to comply with the Newton's law of motion will be equal to the weight of the object. Then Number 3, also we said when the elevator is moving downward, definitely the body will lose will lose weight, and the acceleration will face the downward direction. Therefore, the resultant downward force on the body also will face the direction of the acceleration. And we have this equation for number 3, that is R is equal to M into bracket G minus A, and must be equal to that is the reaction, then must be equal to the weight of the object on the floor of the elevator. That is comply with the Newton's third law of motion. And the last one, which is number 4, that when the elevator is fall freely under gravity, that the body inside the lift will be weightless and continue to float about inside the elevator. Therefore, the A, which is the acceleration, will be equal to acceleration due to gravity G. To back all this one up with the simple equation and formula we derive under these 4 cases now, let's move to 1 or 2 calculation under it before we close for today. Now, let's take this one as example 1. A man of mass 70 kg is standing on the floor of a lift. Calculate the weight of the man when the lift is moving. A, upward with a constant velocity. B, upward with constant acceleration of 5 meters per second square. C, downward with a constant acceleration of 3 meters per second square. G equal to 10 meters per second square. Now, this is just to combine all the cases we treated on one question. Now, from question A, the mass of the man is 70 kg. Mass N, 70 kg. Under the question, G is given 10 meters per second square. Now, but in the case of the first question, the question says moving with constant velocity. And when it moves with constant velocity, don't forget what we explained. The body inside the lift will not gain or lose weight. Then we said A will be equal to 0. Why is it that A is equal to 0? Because it's moving with constant velocity. If that is the case, don't forget, we now say the reaction of the floor of the lift or elevator will be equal to the weight of the body inside the lift. So if that is the case now, then we can now say the weight is equal to mg. M is given, G is given. So we can now say that that is 70 multiplied by 10. So the weight of the body will be equal to 700 Newton. That is for question A. For question B, based on the second case, as we explained during our explanation, upward with constant acceleration of 5 meters per second square. Now A is given 5 meters per second square. Now, since the elevator is moving upward, don't forget we explained that the body inside the elevator will gain weight. Now, the reaction, if you don't forget, R is equal to weight of the object, then which is equal to M into G plus A. That's the formula we arrived at during our explanation. So if that is the case now to calculate the weight of the body now, then to now give us W will be equal to the mass, according to what is written on the board, is 70, G is 10, then A is given as 5. So this one will be 70 multiplied by 15. And 70 multiplied by 15, the weight of the body will be equal to, that is 1050 Newton. That's for question number B of the question. And question number C. The question C, elevator moving downward with constant acceleration of 3 meters per second square. A is 3 meters per second square, but the elevator is moving downward. And when during our explanation, we said when elevator is moving downward, the body inside the elevator then we lose we lose weight. So therefore, we are going to have our R, according to the equation we arrive at, will be equal to W, which is equal to M into G minus A. Why is it minus? Because we said the body will we lose weight. So if you now give us this formula, then our weight now will be equal to, which is weight of the body inside the lid, that's 70 into 10 minus 3. So that's 70 multiplied by 7. And the final answer for the weight of the body inside the lift is moving downward is 490 Newton. Now to convert that, according to the question, that from case number 2 and 3, that in case number 2 we said the body will gain weight. You can look at our answer. That in case number 3 the body will lose weight. Look at our answer. So that's to confirm that according to the Newton's third law of motion, action and reaction are equal but opposite. So inside the lid now, then the reaction upward, the action downward, which is the weight of the body. So according to the calculation now, we'll use this calculation now to convert what we explained to in theory to support it with calculation. Let's take this one as example 2. A boy of mass 50 kg is standing on the floor of an elevator, moving upward with constant acceleration of 2 meters per second square. Calculate the weight of the boy. We need to calculate the weight of the boy. So, since this elevator is moving upward, don't forget our formula. Let's first write out the parameter. Mass is given. Mass of the boy 50 kg. G is given 10 meters per second square. Then the acceleration, constant acceleration, A is equal to 2 meters per second square. Now to calculate the weight of the boy, don't forget when it moves up, then there will be gain in the weight. Then our R will be equal to W, which is the weight, that is the reaction from the floor of the elevator on the body. And this is the weight, which we show the action. Then it will be equal to A into bracket G plus, M into bracket G plus A. That is our normal formula when it is moving upward. So M is given, that is 50 into 10. A is 2, that is plus 2. Then it will give us 50 multiplied by 12. So the weight of the boy inside the elevator moving upward will be equal to 600 Newton. Now from the question 3 on the board, this is the summary of what we've done today. And from the question, from the first diagram below, we saw the first diagram shows a body in an elevator moving upward with constant acceleration. Now we are going to do this one together. You drop your answer in the comment section. When we meet in the next class, I will now tell you who get the answer right. So for now, we are going to stop here, but look at the question, read it. If you are with me and you follow me from the beginning to the end, you see that this is a summary of what we have done. I want to answer in the comment section from A, B, C, D, which one is the correct answer for the question on the board. And as I always say, please don't forget, if you are just joining us, don't forget to like, share, and subscribe. So when I upload a new video like this, you'll be able to get the notification in time. Then I'll be expecting your answer in the comment section. Thank you.